Good morning, students. Welcome back to maths class, the chapter vector algebra. Last session we have to study direction cosines, okay, and properties of vector addition, and scalar multiple of a vector. Direction cosines are what? Cos alpha, cos beta, cos gamma. Cos alpha, cos beta, cos gamma are the direction cosines. Okay, now denoted by what? L, M, N, and defined by what? Cos alpha is equal to what? X by R. Cos beta is equal to what? Y by R. And cos gamma is what? Z by R. These are the direction cosines. Direction ratios are what? ABC. Okay. Next is properties of addition of two vectors. Okay, AB vector, AC vector is equal to AB vector plus BC vector. Properties are what? Associative law, commutative law, vector addition. Next is existence of additive identity and existence of inverse. Next is scalar multiple, lambda into A vector. Okay, now magnitude of lambda into A vector is what? Magnitude of lambda into magnitude of A vector. If two vectors are collinear, A vector and lambda into A vector are what? Collinear. Okay, A vector and B vectors are collinear. B vector is equal to lambda times A vector, or lambda means any scalar. A vector is equal to A vector is equal to lambda times B vector. Then A and B are collinear. B vector equal to lambda times A, or A vector is equal to lambda times B vector. Okay, last over. Today we start components of a vector. Today we have to discuss components of a vector. Okay, first we have to consider a three-dimension space. Three-dimension space. Consider a three-dimension space. Okay, like OX, OY, OZ, be three mutually perpendicular lines. B3 OX, OY, OZ. B3 mutually perpendicular lines. Meeting at the point O. Meeting at the point O. Okay. Next, let us fix the points A, 1, 0, 0. Okay. B point 0, 1, 0. C point 0, 0, 1. In x axis, in three-dimensional space, in x axis, y and z coordinates are 0. You know this already. And B point 0, 1, 0 and C point 0, 0, 1. Okay, it's the points A, B, C. Okay, with the points on what? The axis, x-axis, y-axis, z-axis. Then magnitude of OA vector is equal to 1. Magnitude of OA, O point is 0, 0, 0. Okay, magnitude, I am telling already magnitude of OP vector, position vector of a point with respect to the origin O. Okay, OP vector is what? This is position vector. Then magnitude of OP is equal to what? Root of x square plus y square plus z square. This one is what? Magnitude of OA. 0 minus 1. Using distance formula. 0 minus 1 square. 0 minus 0. 0 minus 0. 1 square is 1. Root 1 is 1. Magnitude of OA is 1. Magnitude of OB is equal to 1. OB. And magnitude of OC is equal to 1. Okay, the vectors OA vector, OB vector, OC vector, each having magnitude 1. The vectors OA, OB, OC, each having magnitude is what? 1. are called unit vectors along the axis. Along the axis Ox, Y, Oz. Along the axis Ox, Y, Oz respectively. And we denote these by what? I cap, J cap, and K cap. These are the unit vectors along x-axis, y-axis, z-axis. Okay, components of a vector means components of a vector let Ox, Y, Oz be three mutually perpendicular lines. Be three mutually perpendicular lines. Perpendicular lines meeting at the point meeting at the point meeting at the point O. Okay, let us fix the points. Let us fix the points. A of 1 0 0, B point 0 1 0, and C point 0 0 1. The points on x-axis, y-axis, z-axis. Okay, the points on the points on x-axis, y-axis, and z-axis respectively. Next, then magnitude of OA vector is equal to 1. Now this using distance formula, magnitude of OA vector is equal to 1. Square root of 0 minus 1 square plus 0 minus 0 plus 0 minus 0 whole square. Magnitude of A is equal to 1. Magnitude of OB is equal to 1. And magnitude of OC is also 1. Okay. Next, the vectors OA vector, OB vector, and OC vector each having, observe that, each having magnitude is 1. Each having magnitude 1. Magnitude 1. Okay. Each having magnitude 1 are called unit vectors. Are called unit vectors. Are called unit vectors. Are called unit vectors along the axis Ox, Y, and OZ respectively. OZ respectively. And we denote these unit vectors I, J, K. We denote these by I cap, J cap, and K cap respectively. Okay. Next, can go for consider a position vector OP, then find out components for this. Find Unit vectors are what? I, j, k are the unit vectors along x-axis, y-axis, z-axis. Okay, magnitudes are what? 1 unit vector. Same, first we have to consider a three-dimensional space. This is P. Consider a position vector OP. Consider a position vector OP. Vector R vector of the point P of x, y, z. X, y, z. Okay. Now this point is Q, R. Already P is there. This is P1. Okay. Consider a position vector OP vector R vector of the point P of x, y, z. Okay. Next, we have to consider now P1 is the foot of the perpendicular from the point P, okay, onto the plane xy, onto the plane xy. This plane is what? Xy plane. Okay, P1 is foot of the perpendicular from the point P onto the plane xy, onto the plane xy. Observe that P1P is parallel to z-axis, P1P is parallel to z-axis. Okay. Next is, since I, j, I cap, j cap, and k cap are the unit vectors along x, y, z. Now you are taking xi cap. This one yj cap. Okay. Now this one you are taking s. Next this one or is zk cap. I cap, j cap, k cap are the unit vectors along the x-axis, y-axis, z-axis respectively. Okay. Next is by the definition of coordinates of P. Now P1P is equal to P1P vector is equal to is parallel to z-axis OR vector. Okay, OR vector is equal to what? ZK cap. Is equal to what? ZK cap. Now we have to take first OQ is equal to XI, OS is equal to YZ, OR is equal to ZK. Next is QP1. QP1 is parallel to y-axis. This means QP1 is equal to what? OX. QP1 is equal to OS. OS vector. OS is equal to what? YJ. OS is equal to what? YJ cap. And OQ is equal to what? XI. OQ is equal to XI. Okay. Next, therefore, OP1 vector is equal to. Now you have to find OP vector components form. First, we have to find OP1 vector. After that, OP is equal to OP vector is equal to OP1 plus P1P. First, we want OP1 vector. I don't know OP1. Already P1P is know this ZK. Okay, OP1 is equal to what? OQ vector plus QP1 vector. OQ is equal to what? XI plus QP1 is equal to what? YJ. XI plus YJ. Okay, and thus OP vector is equal to OP1 plus P1P vector is equal to OP1 is already find out XI plus YJ plus ZK. OP1 is what? XI plus YJ. P1P is what? P1P is ZK cap. ZK. This is this form of vector is what? Components form. This is what? Components of the vector OP vector of the point P of X, Y, Z. This form of what? Components form of a vector of the point P of X, Y, Z. This is components form. Okay, where X, Y, Z are the what? Scalar components of OP vector R vector. Next is xi plus xi, yj and zk cap are the vector components. Means I cap, j cap are what? Unit vectors. Okay, xi cap, yj cap and zk cap are the vector components of a vector. Okay, of R vector. Okay, along the respective axis. Okay, this is also known as XYZ are the rectangular axis and also known as. This is the component form. Alright, now consider a position vector of point. Consider a position vector OP vector of a point P of X, Y, Z. X, Y, Z. Let P1 be the foot of the perpendicular from a point P onto the plane XOY. Onto the plane XOY. Next is what? P1P is parallel to Z axis. Okay, thus P1P is parallel to Z axis. Okay, since I, J and K cap are the unit vectors. unit vectors are the unit vectors along the x-axis, y-axis, z-axis. Along the x-axis, y-axis, and z-axis, respectively. Okay. Next, we have to take, therefore, by the definition of coordinates of P. By the definition of coordinates of P, first we take OP vector. We want OP is equal to OP vector. We want OP1 plus P1P. I don't know OP1. First we have to find OP1. Now P1 is equal to P1. P vector is equal to OR vector is equal to ZK. Next is OS. QP1 is equal to what? OS. QP1 is parallel to y-axis. QP1 is equal to OS vector is equal to YZ. And OQ is equal to XI. Therefore, OP1 vector is equal to OP1 vector is equal to OQ vector plus QP1. OQ vector plus QP1. Okay. Now OQ is equal to XI plus QP1 is equal to YZ. Okay. Thus, OP vector is equal to OP1 plus P1P. OP1 vector plus P1P vector. Okay. OP vector is equal to OP1 is XI plus YZ plus ZK. P1P is what? ZK. This is the vector components of a vector. Okay. And this one position vector of position vector of P of point P. Position vector of point P of x, y, z with respect to O. Is given by OP vector R vector is equal to XI plus YJ plus ZK. Position vector of point P of XYZ. Point P with respect to origin O is given by OP vector is equal to R vector is equal to XI plus YZ plus ZK. This is the components form. Okay, this form of vector equation, this form of any vector is called components form. This form of any vector is called components form. This form of any vector is called components form. Okay. R vector or OP vector is equal to our components form xi plus ij plus zk. This form of any vector is called its components form. Here x, y, z are called scalar components of R vector. Are called scalar components. Scalar components of R vector are copy vector, and xi, yj, and zk are called vector components of R vector. Vector components of R vector along the respective axis. Along the respective axis. Ox, Oy, Oz. And also xyz are also known as rectangular components. xyz are also known as rectangular components. Scalar components are rectangular components are what? X, Y, Z. X, comma, Y, comma, Z. For example, let A vector is equal to, this means OA. This is OA. Okay, OA vector is equal to what? A vector. Components form, for example, 2i plus 3j minus 5k. This is what components form, where 2, 3, minus 5 are the scalar components. 2i, 3j and minus 5k are vector components. For example, a vector is what? Any vector components in the components form 2i plus 3j minus 5k. Okay. Now only minus k is there. 2i plus 3j minus k. Scalar components are what? 2, 3, minus 1 are scalar components. 2i, 3j and minus k are the vector components. Okay, this is components of a vector. Next is magnitude of OP is find out. Length of a vector, OP vector. Length of a vector, OP vector. Length of a vector, OP vector. Okay, length of a vector, OP vector. Consider the right angle triangle OP1, OQP1. We want OP. Right angle triangle OPP1. Now OP is equal to what? OP1 plus P1P. Okay. Now OP1 square is equal to OP1 plus P1P square. We want first OP1. I don't know OP1. Now we have to find from the right angle triangle OQP1. From right angled triangle OQP1. Now magnitude of OP1 square is equal to magnitude of OQ square plus magnitude of QP1 square. We want OP1 only. OP1 equal to root of OQ square plus QP1 square is equal to root of, you know this, OQ is equal to what? OQ vector is xi. OQ vector is xi. Next is, you know this already, QP1 vector is equal to, QP1 vector is equal to S vector is equal to Yj. Okay, and also OP1 is find. OQ is equal to what? Xi. Xi is there. Now magnitude you are taking. Now magnitude of I cap is 1. Magnitude of I cap is 1. Okay, taking magnitude. Unit vector. Unit vector definition is a vector whose magnitude is 1. Magnitude of I cap is 1. Magnitude of j cap is 1. Magnitude of k cap is 1. Okay. Now QP1. Now OQ square is x square. Magnitude of OQ square is x square. QP1 is what? Magnitude of Yj. Magnitude of Yj is, now we are taking y square. Okay. Already I am telling that magnitude of OP vector is equal to root of x square plus y square, the position vector of a point. Position vector is already I am telling that second session, position vector of a point. Okay, magnitude of OP vector is what? Root of x square plus y square plus z square. Then magnitude of OP1 is what? Root of x square plus y square. OQ is equal, magnitude of OQ is x. Okay, magnitude of xi. Magnitude of x into magnitude of I cap. Magnitude of I cap is 1. Magnitude of I cap is 1. Now x square. Magnitude of OQ square is x square because magnitude of ijk value is 1. And therefore next is and from the right angle triangle, and again from right angled triangle OPP1 or OP1P. Okay, OP1P. Therefore, OP vector, magnitude of OP square is equal to magnitude of OP1 square plus magnitude of P1P square. Consider the right angle triangle OP1P or OPP1. OP1P. Okay. Now we want only magnitude of OP vector is equal to root of OP1 square is already found out. Now once again write OP1 square plus P1P whole square. Okay, magnitude of OP vector is equal to root of OP1 square is what? OP1. Now we'll get OP1 square is, now we'll get only x square, or magnitude of OP1 square is equal to x square plus y square. Okay, OP1 square is x square plus y square. P1P is what? P1P. P1P vector is equal to OR vector is equal to ZK cap. Okay, magnitude of Zk. Magnitude of Z into magnitude of K cap. Magnitude of K cap is 1. Magnitude of Z square is 1. Okay. Now Z P1P vector is Magnitude of P1 B vector is Z. Square is there. Z square. This is OP vector. Length of OP vector is what? Length means what? Magnitude. Length of a vector or magnitude of a vector. Magnitude of OP vector is equal to what? Root of x square plus y square plus z square. Okay. The length of any vector means the length of any vector, length of any vector of R vector, length of any vector R vector is equal to what? R vector or OP vector xi plus yj plus zk. Length of any vector, for example, a vector is equal to 2i plus 3j plus 5k. OP vector is equal to R vector is equal to xi plus yj plus zk. Then magnitude of OP vector is root of x square plus y square plus z square. K is given by magnitude of OP vector is equal to magnitude of R vector is equal to root of x square plus y square plus z square. This is the length of a vector. Okay. For example, for any vector A, let A vector is equal to 2i minus j plus 3k. Then find out length of a vector A vector. Then magnitude of A vector is equal to, now 2 minus 1, 3 are the scalar components. 2i and minus j and 3k are the vector components. Magnitude of OA is what? 2 square. Magnitude of OP vector x square. You can taking only coefficients as a x, y, z. X square plus y. Xy plus yj plus zk. This is what component form. This form is what? Components of a vector. Components form. 2 square. X is what? 2. Y is what? Minus 1. Z is what? 3. Okay. Now x is 2. Y is minus 1. Z is 3. X square plus y square. Y is minus 1 whole square. Don't take 2 square is not equal to 2 square minus 1 square plus 3 square. Okay, you write this 4 minus 1 plus 9. It's not correct. Okay, you have to take whole square plus 3 square is equal to root of 2 square 4 minus 1 square is plus 1, 3 square is 9. Now the answer is magnitude of A vector is root 14. Magnitude of length of A vector is what? Root 14. Root 14. Okay. Not equal to root of 4 minus 1 plus 9. Don't take this one. Okay. This is the length of a vector. Next is some points are there. That A and B, A vector and B vector, be any two vectors be any two vectors, be any two vectors. Then find out sum or resultant of the vectors a vector plus b vector. First point. Second point is if two vectors are equal, a vector and b vector. Okay. Let a vector and b vector be any two vectors given in the components form. Given in the components form. Given in the components form, write down that a vector is, you are taking any vector a1i plus b1j plus c1k, or a vector is equal to a1 a2 plus a3. Now b vector is b1i plus b2j plus b3k. Okay. Now let a vector and b vector, that is a vector is equal to a1i plus a2j plus a3k. This is what components form. This is the form what xi plus yj plus zk. a1, a2, a3 are the direct, a3 are the scalar components. a1i, a2j and a3k are the direct vector components. And b vector is equal to b1i plus b2j plus b3. Okay. Not write the direction b1 vector, not b1 vector. This is the components. Okay, b1, b2 are the scalar components. Don't write vector. Don't write symbol this arrow mark. Okay. A vector. This is b vector. Now then, first one. Then sum of or resultant, the sum or resultant, the sum or resultant of a vectors a vector and b vector. Resultant of the vectors a vector and b vector is given by a vector plus b vector. A vector is a1i plus a2j plus a3k, plus b vector is b1i plus b2j plus b3k. Okay. This implies a vector plus b vector is equal to, separating ijk, a1 plus b1, a1 plus b1 into I. Okay. I, j, k. Unit vectors. Okay. Plus a2 plus b2. a2 plus b2 into j vector. Cap. Next, a3 plus b3 into k cap. This is resultant of the vectors. Okay. Second, if a vector and b vector are equal, the vectors a vector, the vectors a vector and b vector are equal. That is, a vector is equal to b vector. A vector, you know this already, a1i plus a2j plus a3k, equal to b vector is b1i plus b2j plus b3k. Equating coefficients of ijk. Okay, this implies a1 equal to b1, a1 equal to b1. Equating coefficient of j, a2 equal to b2 and a3 equal to b3, a3 equal to b3. two vectors are equal, that is a1 equal to b1, a2 equal to b2, and a3 equal to b3. Third point, the scalar multiple of a vector, the scalar multiple of a vector a vector by lambda, that is lambda into a vector is equal to lambda into a vector is a1i plus a2j plus a3k. Then lambda into a vector, all the components you have to multiply, then all the a1, a2, all the elements multiply, lambda into a1 into r plus lambda into a2 into j plus lambda into a3 into k. This is scalar multiple of a vector. These 3 points. Okay. For example, let in the components form two vectors. Let a vector is equal to 2i minus j plus 3k, and b vector is equal to 3i minus 2j plus 5k plus 5k. Then a vector plus b vector. A vector plus b vector. Resultant of the vectors or sum of the vectors. Both are same. Then a vector and b vector is given in simple question in 1 mark. Then find the resultant of the vectors a vector and b vector if a vector, this type of vectors are given. Resultant means what? Then find the sum. Addition. A vector plus b vector. 2i minus j plus 3 plus 3i minus 2j plus 5k. Okay. Now a vector plus b vector is equal to 2i plus 3j. Separating I, j, k. I, j, j and k, k adding. 2i plus 3i. Or I is common. 2 plus 3 is 5. 5i. Next minus j minus plus into minus minus. Minus j minus 2j minus 3j. Plus 3 plus 5 8k. Okay. Now second one. This is first. Second. If a and b are equal, if a vector is equal to b vector. Okay. If I know a1 equal to b1, now we have a vector is y. Now we get, for example, in this one, lambda value is there. For example, in any vector a and b, 2i minus j plus lambda k. 2i plus minus j plus lambda k. In this one, xi is there. Then find out lambda and m value, or x and y value. Okay. Now, second one, we have to find 5 times or 3 times a vector. Scalar multiple of a vector by 3. By 3. 3 into a vector. A vector is y minus j plus 3k. Each one multiply 6i. 3 into a vector is equal to 6i minus 3j plus 3 into 3, 9k. This is scalar multiple of a vector by 3. By 3. Okay. Next we have to discuss vector joining two points. Vector joining two points. Okay. To stop this one. Tomorrow we'll start vector joining. Thank you.